everyone, and welcome to another episode of The Curious XX, a podcast where we celebrate brilliant and inspiring women carving remarkable paths in STEM. Today, we're pleased to introduce Ms. Shalvi Mahajan, a senior AI scientist at SAP and featured on PrimeView as one of the top 10 most impactful women in technology in 2022. After studying data engineering and analytics at Technical University Munich, she began her career as a data scientist at Allianz before joining SAP, where she now works as an AI scientist. Beyond her technical expertise, she's an active speaker and passionate advocate at various conferences like Women Tech Network, where she's shared her insights on emerging AI trends and software development. With the rise of AI, LLMs, and thinking machines, we plan to dive into a discussion on a topical subject: bias in AI algorithms. With Ms. Shalvi, we hope to uncover where bias comes from, how language can reveal bias, and how we can tackle bias to benefit minorities and real world industries directly impacted by it. So, greetings, Ms. Shalvi.
Hi, and thank you for organizing this, Adya and Dia. I'm really impressed with what you're doing, and when you came up with this idea, I really wanted to do this with you guys. So thank you for inviting me.
You're welcome, and thank you for coming to speak to us today. We're really excited to talk to you. So, just to get started, as you move deeper into your work with AI and you started working with real world data, what first made you aware of this problem of bias in AI systems? And what first made you aware that it's such a serious issue in the world today?
Yeah, so I was in software engineering before, and in my bachelor's I moved to France to do some internship, which was on data analysis. So that was my first time when I actually moved into something for data science. And I really enjoyed it. So I worked in Samsung as a software engineer, where I was just the only girl in most of the teams. Um, and I used to find it very strange. I also wanted to dig deeper into why this could be. The reason, even though we are in 21st century, everyone in at least in colleges, also the distribution in India is not that perfect. But yeah, so this made me very curious. And anyways, I wanted to go deeper into data science after my internship, so I decided to move to Munich. Um, Now here I worked with a lot of data during my masters, during my time at SAP, um, and also in my personal projects. And often I have seen that there is a lot of bias in the data, but we need to handle this data very in a very efficient and a nice way so that it does not affect the future. It is a serious issue, you know. It is a serious issue because the world depends on it. After ChatGPT, I think every one of us agrees that it's an AI era. It's going to be the AI is going to stay. It's not just a fancy thing anymore. So when we are building the future, why not make it better, right? Because biases can affect a lot of minority groups, a lot of underrepresented groups. Yeah, so that's how I thought that after looking at so much data that there is bias because the society has those biases and the data has those biases. So I wanted to dig deeper into it and communicate, make people aware that this exists. Yeah.
Yeah, I think that's a really good point that bias is more present and it's become more important, especially in the era of ChatGPT, because so much of our information comes from LLMs and so much of the LLM is based on data that we provided, and that's why bias in data has become even more important in today's world. So I wanted to understand, how does this data kind of become biased in the first place? Like, where does the bias originate from? Is there a specific place it originates from, or is it just ever present in the data?
So bias in AI, it does not come from one single place, you know, it comes from the entire AI life cycle. And first, the data is being collected, right? So the collection that happens, how does it happen? It happens from the people. People send their data, and that's how it gets collected. And now our country is not, our whole world is not equal enough, right? So there are biases for the underrepresented groups, for the minority groups, for the gender bias, racial bias. There are a lot of biases based on the different cultures, different countries. There exist a lot of them, right? So whatever the data is collected, that comes in it. And now even some underdeveloped countries, for example, for the gender bias, for the underdeveloped countries, there are some women who doesn't even own the phone, so their data is not even being collected. And that's like, of course the data will be skewed right towards the male group. So that's how the data is introduced with the bias in the beginning. And now comes the stage when the data is there, but the labeling has to happen. It comes to the responsibility of a scientist, the data scientist. Now, the labeling happens with a group which is also not diverse enough. So there are not many women who are working in AI fields, right? So the labeling is already biased because there is not diversity in the groups. And the second step already is skewed. Now, the third step is when you push everything to the model, you need to, before pushing everything to the model, you need to do some feature engineering. Now you did every feature engineering on the data that was already biased. So the model becomes more biased, right? Model is just it's a mirror. Machine learning model is nothing but it's a reflection of whatever we feed it into it, right? So that creates a big problem. And that's how, due to all these patterns that emerges in the model, in the data, the model understands whatever we feed it. And yeah, they already exist in the world. It will exist in the future as well because we didn't treat it well. Let's put it like that.
Yeah, definitely. So as you said, the model is simply a mirror of what we feed into it. And you spoke about how the world is inherently unfair. So obviously some people won't be able to feed data into the model and that'll affect it. So so that what you're talking about is a lack of data, I'm assuming. But do you think that there's also a problem because of the wrong kinds of data we're feeding into the model? And do you think that some kinds of data are more prone to bias than other kinds of data? Is there, a distinction to be made there?
Yes, exactly. So some kind of data like the historical data, the language data, the behavioral data, these are more prone to bias. When I say historical data, it's like during the hiring, some groups are not even considered just because they are something that maybe the group of people doesn't think they are qualified for the job, right? So the resume won't even pass the screening round, and that's very strange because I think the person should be assessed by their skill set and not because they are, for example, women. So the historical data is one of the data types that are more prone to bias. Then, for example, the language. In the language, the text, whatever the text has, the translations have. There is always certain groups that are represented with a he or a she. Like the doctor always somehow is a he in the text, in the large text, because most people I think often recognize it that way. And for example, the translation tools you use, they always, whenever there's a doctor, they translate it with a he automatically, which is very strange, right? But they are doing what the data showed them in the corpus, right? So actually the issue is there is already historical inequality in some cultures that I mentioned, right? Social norms which are encoded into the language and the machine learning model, and all the decisions that we made in the past, that the world made in the past, are now into the data set. Data set is huge for sure, but if there is for example, into a large language model, you don't feed a small data, right? So it's a very big data, like I don't know how many millions or how many rows, but every piece of row or all the data that they have definitely does not have the equality in it. And maybe in the next few questions, I can even talk about how we can make sure before feeding the data into the model to achieve that fairness. Yeah.
Yeah. So as you said, the doctor example was a very interesting one. The that in languages they sometimes translate doctors only to males, and I saw this in Spanish as well. Like they now Google Translate has kind of updated it, and they give you, if you put doctor, they give you two options. They give you a male and a female one, but before it used to be just the male one that would come up automatically. So yeah, but so these models kind of just produce this data based on the input that we give it, but what role do humans play in the labeling of the data itself, and how does that contribute to bias? Um, and if you could provide like some more examples apart from like translation.
Yes, so actually humans have a big role in treating this bias, right? So whenever like the group of scientists have to label the data, if there are diverse groups, so I also might have some assumptions, some shared assumptions, right? As a person, even though when I think deep into it, maybe I will think, no, that's wrong, that's wrong. But that's how we grew up, right? In such a world which was anyways unequal. So every human has their own bias. So that's why I said it should be a diverse group. Whenever the labeling happens, it should always be a diverse group, like equal number of male, female, races, all that considered, and then coming up with something. When you will label the data, when such group of scientists will label the data together, they will anyways ensure that, okay, this means the labeling should be this row means labeling should be that. But if already there's like, I don't know, in a team of 10 there are 9 male and 1 female, you can only already imagine how the labeling will happen, because the mind framework, the thinking is very different sometimes when you come from different cultures, different races, genders, and so on, right? So yeah, it's all because we all share some kind of shared assumptions, and these stereotypes somehow stay with us for long, and that's what we should fight when we are anyways planning to now build a new future, right? Yeah.
Yeah, definitely. So till now we've discussed about how bias is in data and how that can pose a problem. But do you think that bias can also be introduced because of the design of the model itself?
Yes. So it's like I said, it's not just it's not just the beginning stage or the initial stage, it's just the whole AI life cycle. And when I say AI life cycle, it also means that the model design can also amplify it, can also increase the intensity of what already was existing. So, for example, in the machine learning model, there's always an objective function. Now, this objective function, if we for example, in reinforcement learning, if we make sure that the how the maximum revenue or the profit is calculated, it can also somehow try to reduce that bias. Now, if that is not built in a proper way, for example, if the minority group was always misclassified, and the objective function was not set in such a way, then it will never be able to learn that it has to do something about it. So the right way would be, in terms of, for example, reinforcement learning, to put a penalty whenever this misclassification happens. And over time, model will learn with that objective function that if it goes wrong, it will be charged in negative, so that it maximizes the profit. It needs to always, it's an iteration, it needs to always gain the maximum revenue or the profit or the accuracy or whatever the objective function is. So architectural choices, feature engineering, data, thresholds, everything together, like, is the result that we get. Yeah, so the we as a scientist, as a data scientist, I really feel, and in all my talks I say, that responsibility is a big thing. Ethically, whatever we do right now will definitely be the next generation's problem. So ethically, we should be very correct. We should make always responsible AI. Yeah.
Yeah, I think that's really interesting. Like what you were talking about, like you're sort of giving feedback to the AI so it can correct itself over time. And that's interesting from the design perspective. So, moving on to language, because you work closely with natural language processing, which, from what I understand, it is basically just how computers interpret human language and the way we communicate. What do you think makes human language especially tricky for computers and machines to interpret in a fair manner?
Language is a very tricky thing, in my opinion, right? So, because based on the culture, the tones change. The tones change, the understanding change, the assumptions change. Whatever you say in one country may be wrong in the other one. So, language, it's very hard to determine what the context was just by the text, the corpus. It's very hard. And that's how you can imagine how it is hard for a model as well to understand in what tone something was said. So, dealing with language tasks is harder. That's why it took so long to build something so powerful like GPT or other LLM models, Gemini, and so on. Otherwise, I think the whole process started long way back, even before we all were born. But it took so long because it's really hard to build something like that to feed it such a big corpus into the machine, then all the GPUs and so on, and a lot of energy. There's a lot going on than just what we see in every user's hand. Um, so I mean, it's however we treat this language will what the LLMs will understand. But like I said, it's very hard. The machine translation is hard because you need to, for example, this he and she, doctor and nurse example, right? So it's a neutral profession, in my opinion, doctor or nurse. It's a very neutral profession, but somehow whenever we put something in translate, like I think Adya said, in Spanish the results are wrong, or in any other language it automatically relates it to one of the genders, something like that. So it's based on the stereotype. It found such patterns, such statistical associations in the corpus, like there were more male associated with the doctor profession than females, and that's how the model learned. Sentiments, whenever I say something, maybe my way of saying doesn't represent the same sentiment as would be in some other country, the emotion, sentiment analysis, all that is actually what statistical associations the model find in the data. It is based on stereotypes, but it not often represents all the context from that data. You know what I mean? Yeah.
Yeah, that's very interesting. Like, especially the tones that you use in your natural, like, way of speaking can really affect the way that specific sentence is interpreted. Like, for example, if you're speaking sarcastically, the model may not really understand that.
Exactly. Yeah.
Mm. So, what kind of NLP tasks, like specifically translation or sentiment analysis? I think we already spoke about translation, but sentiment analysis or speech recognition, how are they vulnerable to gender bias as well?
Yeah. Yeah. So machine translation, I already told about. It's based on the statistical associations where some groups are often represented with something more than the minority groups. Sentiment analysis is also like words sometimes associate often with negative, positive, or neutral reaction, right? Similar expressions, if even if stated in different tone, may turn opposite. So it's hard for the model sometimes. Speech recognition. So in the past, there were studies where it was shown that female voices, the higher pitched voices, were not being able to identify on the inference stage because the training data was already skewed with the male data. So things like that. So model has to infer something which was never in the data set, so it's hard for the model. So that's why even if the data was like had different classes and not sensitive to any group, just data, financial data, which has different classes, not sensitive to any group, there's always one rule of data science to make the classes balanced. Even if we don't do that at the inference stage, you don't know, maybe the let's say there is 0 and 1 class, and 0 class was way less than 1 in the training data, and in the test data you got totally opposite test set where 0 was higher than 1. Now see how the model accuracy will be. It will be way lower, right? Because 0 class was anyways too little in the data set that was fed into the model. So yeah, so something like that. So it is hard for the model to do something at the inference stage, something which it has never seen in the training stage.
Yeah, I think that's very, very interesting. And this relates to the next question that I wanted to ask, which is about if machines can ever really understand what we're trying to say, like in the future as well, will it ever be possible that the machine truly understands the intention that we're trying to communicate with language? Or is it only ever going to remain a human-only skill? Like creativity, for example. Um, Even though ChatGPT right now can generate whatever you want it to generate, is it truly creative? Like, will machines ever really be able to understand what we're trying to communicate in the
So
future?
at the moment, it's a bit difficult, right? Humans still hold the power, So you ask questions from ChatGPT, we all do, but in the end, it will tell you n number of ways to do something, right? And in the end, it's still your call what you decide to do. It's still your method of doing something. So humans still hold that power. Because we've lived experiences, we've lived emotions, ethics, everything, awareness. We have the awareness of the situation we are in. So at this stage, at least, machines are very good at predicting the likely intent of something which it has seen in the data set, or not seen, then it generates, right? It hallucinates most of the time. The risk only comes when there is a confusion in the prediction, in the at the inference stage, when something was never seen and it starts hallucinating. And there is confusion because of the machines don't fully understand everything: cultural context, stereotypes, emotions, things like that. So so at the stage, I think we are far from there. But yeah, so humans still hold that power, and I'm happy about it because we can still give feedback. Yeah.
Yeah, definitely. It's a good thing that, we have human nature still matters in today's world, and I think it always will. But I think AI models are also improving as we
Yes.
speak. In the future, it it may get harder to distinguish. So now just moving on to ways to tackle bias. Can you give a brief overview from a machine learning perspective on the most effective techniques from your point of view, sorry, to tackle bias?
Yeah, so I already talked about the collection of the data should be with the diverse group, the labeling should be with the diverse group, but let's move to the next stage. So now we have the data. Let's say it's skewed. It's not perfect, it's skewed. We need to rebalance this data set. So we have an imbalance, let's say with the male and the female group. Male group has 80% and female just 20% of the data set, the rows that they have. Now we need to balance it. So there are some techniques like SMOTE, upsampling the data, downsampling the data, where what happens is, like, upsampling, for example, is just you increase the size of the minority class. And how do you do that? You generate either the synthetic data or replicate what you have with some changes in the minority group data that you have, so that it's at least 50-50 or 55-45 or something like that, like very close to each other. You do that during the data engineering, this kind of stage, right? Then if for example you didn't find too much diversity, or like this minority class was too little that you cannot do variations in the data to increase the size, then there is an option to either decrease the size of the majority class. But it's often not recommended, because if you do that, you reduce the whole data set as well, right? So it's better to feed more data than the less one. There's third method, where what you do is, basically the majority class remains as is. We give weight to the class weight. We basically give to the both the classes. The majority group remains one, but for example, for the minority group, we give, whenever the model is doing something, inside 2 into something like that. So we gave the weight twice. So this is how the rebalancing of data set works. So that's the first stage. Then the second one is on the model level. This is like what I said about the penalties, right? You can tell the model that there will be penalties if you didn't give correct answers, or if you misclassified, if you basically misclassified the minority group. And while the model was iterating in the loops, it will always check its maximum profit or accuracy for that particular class. And if it is misclassified, it will give it -1, -2, something. You need to set that objective function. Now, the third one is on the evaluation level. Now, let's say you have a machine learning model, which is ready, and I think you made sure everything was fine. Now, at the evaluation stage, often what we do is we calculate the group, the total accuracy, the total precision, the total recall. These are the performance metrics, how you measure how good your machine learning model was. You don't do that in such a case where such sensitive groups were involved. You calculate the group-based metrics, not the total one. You calculate accuracy for the male group, accuracy for the female group. And now you will see, like, let's say the sample for in the test set for male group was also a lot and female group was less, but the accuracy will be checked only on that particular number of rows, not on the full. Because if you do the full, anyways, if the male group was 90% and female was 10% in the test set, the results will be, even though they are 100%, they might be just because the 90% was the male group holding it, right? So it will be true for them and maybe wrong for the female group. You will never even see why it was wrong. So that's why group-based metrics, I always say, it's very important to see per group how your performance metrics behaved, and then see if it was not good enough, then try to do everything again. Try to balance your data set properly, try to do the better way of doing the machine learning model, building the machine learning model, and then check again. Yeah.
Yeah, I think the 3 stages was like it. The explanation was very interesting, and how, especially at the evaluation level, how you can calculate the precision for a specific group. I think that would really make a difference in understanding how accurate your model is for that specific underrepresented group. So, you mentioned creating synthetic data as an example. So could that um, help reduce? So I know that it helps reduce bias, but can it also introduce some other risks by creating some artificial data?
Yes, yeah. So when you are building, I mean, synthetic data is useful for the scenarios where you have less data, right? So it can absolutely help, but it also, like you said, it also has its own problems. So whenever you are building such a synthetic data, you need to ensure that you try to cover every single scenario and possibility, the underrepresentation, the minority group, the ethically wrong things into that data. So that's the big responsibility of someone who's building the synthetic data, because otherwise, whatever again, the whatever stereotypes, assumptions, whatever we hold, we will still put it again into the synthetic data, which still doesn't solve the problem, right? So, for example, this he/she example, right? The doctor nurse example. If you have such a data and the female is very little related to the doctor, or male is very little related to the nurse in that data set, maybe try to ensure more examples, like with the age, the female linking more to the doctor, something like that in your data set. Like it's a tabular data. Try to have more such examples while creating the synthetic data. But of course, it has its own risk. So that's why getting a diverse opinion on whenever you are building something like that is good. And even in the previous question that you asked me, I think the last stage after evaluation would be to get feedback, to get some other people's or humans' feedback. Yeah.
So earlier you mentioned feature engineering as another method to tackle this problem. So can you just explain what feature engineering is and maybe some examples of it, and how can it help us tackle bias?
Yeah. So, I mean, feature engineering is what we do when there are some, let's say, I don't know, some numerical attributes or something which we can accumulate as one. So what we can do in such sensitive data is aggregating behavior over time instead of doing a single event. transforming some things into neutral representation and not linking with a particular group, for example, removing some sensitive attributes, making some changes in the data set. For example, if there is a financial data and we say, like this credit, because there's a classic example where it has been found that even when women are ordering the credit card, they are given lower limits than male, which is, I don't know, very strange. So something like that. So what we can do in such cases, we can have more examples where like women of good qualifications, everything, and very similar to any other group, have the result or the label as very similar. So something like that. So feature engineering is very, very important. It just depends on, like this, in case of this credit thing, whether the credit was paid on time or not by the male or the female. When you are doing this feature engineering, make sure like both the groups are equally split between paying and not paying. Not like women are mostly towards paying after the deadline and male are often across paying before the. If that exists in the data, try to ensure that the feature, when you do the feature engineering or upscaling or upsampling of the data, you ensure all those examples are included to make, exactly, the diversity in the data set.
Yeah, based on what you just said, like related to feature engineering and how you said ensuring a split between male and female data, is it possible that sometimes if you do upsampling or if you do feature engineering, you could skew the data in the wrong way, and get the conclusion that was like that's wrong?
Yeah, it can. Yes, of course, it can happen. So that's why, uh, just don't do something blindly. Just do your proper research. If maybe whatever data came was actually explaining something. You just thought that there are sensitive groups involved, and that's why we are doing something like that. So it's important to do your full research, full understanding of where the data came from, which country, which company, for example, or whatever. Like, maybe it's not always the job of the data scientist, but everyone in the team to ensure that where the data collection happened, the sources, and so on. So it can be that it is going in the wrong direction, but yeah, you need to make sure when you are checking, doing the inference on the test stage, for example, doing the inference in the real world to get that feedback from diverse group again, so that whatever you fed into or whatever you built, was it wrong or right.
Yeah, I think it's important to be aware that what we do can also affect the
Yeah.
machine learning model, and that's why it's like super important to be ethical.
Mhm.
So do you think we'll ever reach a point when models can like be self-correcting and be sort of aware of the bias and then skew the data on their own and correct it, or is that very, very far into the future?
I think it's very hard for the model to be bias aware. I think in my opinion, in the future, it can only be bias detector and not bias aware. Why? Because bias aware require values, require understanding, require how the world is evolving. Society has evolved and changed so much and so quickly it is evolving. It's hard for the model to keep up. So I think awareness requires a lot of value, understanding, and I don't think AI will, at least not now, which it has reached that stage where it will be bias aware, but maybe it will be more bias detector.
Okay, so it can detect bias, but maybe not consciously be able to correct itself because that
Exactly.
involves, yeah, a more complex understanding. Okay, so we're talking a lot about reducing bias, but do you think that there's a trade-off that comes with this? And are there situations in which reducing bias can actually compromise on efficiency of the model itself?
Yes, it will. But I think fairness and accuracy are not the opposites. I would rather build a fair model than build a very accurate model, because, like I said, the total accuracy, if we calculate on such a sensitive group, it will always be higher because your data is already skewed towards the majority class. So it will always be higher. But I would rather build a fair model which will also represent or give fair enough accuracy for the minority groups as it would give for the majority group. So I think it's not. They are not the opposites. They need to go hand in hand. We need to balance somehow to also get a better accuracy when we push that model into the world. And also, it should be fair enough.
Yeah, I think that's a important perspective to keep in mind when building data models, and it's not something that everyone would think about when achieving high accuracy. So now more real world impact of gender bias in these data sets. What are some real consequences of these bias models, not just for women, but also for other minorities?
Yeah, yeah.
Like for
That's
example,
very,
you mentioned the resumes and how they kind of got
yeah.
rejected solely based off their gender.
Yeah, that's a very good question, actually. So, the resume screening, the credit card history, that's sometimes not given equally to the minority group as was for the majority group. That I already mentioned. One study I was reading through is, do you know about these cancer apps, like the melanoma detector apps, before you go to the doctor, because everyone wants to see what's like what happened to them right away, rather than booking a doctor's appointment and go there, because people are scared, right? We are scared about what the outcome could be. So there are certain apps where there are machine learning models detecting whether you have melanoma or not, just by looking at the photo of the mole, for example. So since the data is not balanced enough in the real world, also that's how the collection happened and so on. So there was a study where it was found that a black women data is not good enough for such cancer apps. See how risky that would be if a black woman is trying to take a photo of her mole and putting it on the resume on the cancer screening app to find out whether she has melanoma. Maybe she will just get the answer, no, you are totally fine. Even though she's on first stage of cancer, no, you are totally fine, and she will be relaxed, right? So this is very risky. I think from the healthcare diagnostics in this industry, it's very, very risky to give such an answer. I think the machine learning model, if made properly, it should just give an answer that it cannot state that. It cannot tell you, you need to go to the doctor, right? That would have been even better than just saying, no, you don't have it. Yeah.
Yeah, there's a lot of examples of gender bias in data, and like so many of them are so male focused that it's very difficult for them to like detect health problems in females, and especially in the healthcare domain, ethics plays a really really big role. So um are there any misconceptions that people have about data bias or in AI that you would maybe like to kind of do like a myth busters on?
Yes, one thing I mostly heard from people is AI is gonna solve everything. No, it is not. At least not now, right? So if it is going to solve everything, which means it should solve all the stereotypes, all the assumptions, because I think I really hate to see it that even today we are still on the same page as we were before. We have improved for sure, but as a society, we are still failing somehow in for representing a lot of groups, right? So AI is not going to solve everything. We need to be responsible as a user, as a data scientist, as any other citizen, right? Second, bias is not a bug; it's a reflection. Like I said, the model only do is a mirror of whatever we did to it. So it has to be handled properly. So bias is not a bug, actually. It's the accumulation of whatever we built in the AI cycle, the model choices, the design, the data, and so on. So, yeah.
Yeah, definitely. So you spoke about how we need to be responsible as users. So what do you think that an everyday user can do when interacting with AI to avoid reinforcing this bias into the system?
Yeah, that's actually a very good question because we also hold that responsibility as a user, right? And so I think whenever you chat with a large language model, whenever you ask some questions, we all do, right? Um, Users don't know they actually have a lot of power. Then they realize give feedback whenever you are prompting something. um, like if you think your LLM model didn't respond the way you ask the question, you should give feedback, because these models have one good thing: they also learn iteratively with the feedback you give. So this kind of thing the users can utilize. The way you prompt can be improved. It should not have its own biases within, but whenever you get an answer, you should give the feedback to the model that no, this was not correct, or this has to be said in such a way, something like that. Yeah.
Yeah, I just have a follow-up question on that. When you said that the way that you prompt can also be improved, to what extent does the bias that the user has affect the bias that the LLM like presents in response to the user? Or does
Yeah,
the
so
LLM sort of have like a baseline level of bias and then like it increases if the user is also biased? It's
increased,
prompt.
right? Because the models are not perfect enough. So it has statistical associations which identified patterns with some groups and some not. I mean, in some ways. And if the user already is biased and it's asking such questions, then it will amplify it. There's no way, but uh, it's hard to like make sure everyone is doing the job correctly. Our job, at least what I feel my responsibility, major one, is to make people aware that something like this exists. You won't believe that I've been to so many conferences and still people do not understand why this bias is, or they are not even aware. But when they hear me talking about it, then they can relate examples from their lives, like while chatting with the chatbots or while being in such some groups, and then they start asking me questions about it. So awareness is still missing, and I think that's very important.
Yeah, that's a good point that you raised about awareness and how, yeah, I think data bias in general is sort of like under the shadows and people don't really know about it that much. So, as a woman yourself, what has your personal experience been in entering this male-dominated tech field, and how have you kind of encountered some challenges with that?
Yeah, so I have been in the teams where I was like the only women in the tech field, in the AI fields, or the only scientist in the group of males. It was definitely not easy. It is hard when you are in the beginning of your career and you need to always raise your voice to make your point. It is hard. It is very hard. In the beginning, you will be afraid to do so, right? You won't speak up so much because you will be like, okay, anyways, anyone, nobody is listening to me. It's fine. I can also just obey whatever everyone is saying. I think everyone is fully confident enough when they have done all their masters and studies and have done well in their career. They will definitely reach a point beyond this imposter syndrome where they will want to speak up and speak up. I think speak up confidently because you are as much skilled as anyone else. It took some time for me to make my voice heard without over explaining, but but we reached there. And the dynamics change. Dynamics also evolve in the team then. So I think you need to fight this imposter syndrome. I don't think imposter syndrome is only with women, but I think anyone who feels not being heard, it can happen with them. But you definitely need to fight it up so that you are confident enough and people listen to you the next time you speak up.
Yeah, definitely. And I think with the work that you're doing, you're going to learn how to tackle this bias, whether it's human or algorithmic. So it can benefit your own life as well. So, just to end this discussion, what advice would you like to give to girls who are interested in STEM or AI who may feel intimidated entering the kind of field that you're in right now?
Yes. So first thing I would say, don't wait to feel ready. Sometimes I have the feeling that even I feel that I'm not fit for this role. I'm not ready for this role. Readiness is a myth. It's a myth in the fast moving fields sometimes, like AI. um, you need to push yourself sometimes into that, because what happens is, like, a lot of people told me, you will be good in leadership, you will be good in this, and I always thought, no, I think I'm fine with wherever I am. I just forced myself into some situations where I know that whether I'll be good at it or not. So you need to see for yourself. Now I'm starting some leadership roles in at SAP as well. Just it's not that something I will definitely do. I don't know. That's the point. I don't know, but I want to try it out for myself, and see if I can do it. If I feel comfortable doing it, something like that, or I don't feel it. I can definitely go back to what I was, right, a scientist. So readiness is a difficult thing to assess. Let's put it like that. Um, Focus on building strong fundamentals. The confidence comes with knowledge. So if you have a lot of knowledge, if you have done a lot of practical things, your fundamentals will be strong. And then you will have confidence to speak up, to fight that imposter syndrome if you have one. Um, Find mentors, find people who can support you. I had very good mentors my whole life, and still I have a lot of them. Plan one-to-ones with them, because with the help of the mentors you will see, like, 5 years after, how your life can be, and how you want to reach to the stage what you want to become. Yeah. So speak up. Don't get overwhelmed with situations, because situations may put girls in such a thing where you feel you are not good enough, and that's not true.
Yeah, I think that's a very strong piece of advice for all young women out there. So, I just want to provide a short summary of what we discussed today and then conclude with the podcast. So, one of the most powerful takeaways from this conversation was that bias in AI is not an accident, it's a reflection of human society and the systems that we have built. And through Ms. Shalvi's experience as a software engineer, we were able to understand that bias doesn't appear only at the final model stage of any machine learning or large language model, but it enters at every single step of the AI lifecycle, from how the data is collected to who labels it to how objective um, the model is and how the penalties are defined in models. So, through your work, we were able to understand how AI models don't truly understand the world. And in this conversation, one of the most important things that I understood was that, especially with language, meaning is shaped by like cultural appropriation, tone, and context, which humans can intuitively grasp, but machines can only approximate, and they only understand the world through data and probability. So, this is why language based systems like sentiment analysis or translation that we spoke about are very vulnerable to reinforcing the social norms that are already present. Another thing that really stood out to me was responsibility. And fairness isn't something that we can automate in an AI model. It requires diverse teams and like diversity through the grassroots level in the data itself and through thoughtful evaluation of the model. And one of the most interesting things I found was the evaluation based on group metrics, not just evaluation of the model as a whole. And as you highlighted, fairness and accuracy are not opposites and they must go hand in hand, especially in fields such as healthcare. So ultimately, AI will not fix society's biases, but as we were reminded in today's podcast, responsible AI begins with responsible people, data scientists, engineers, and even the users themselves who are aware of their own assumptions and biases, so that we can build systems that serve everyone more equitably. Thank you so much for all your inputs today, Ms. Shalvi. I think it really helped us understand gender bias in AI really well. So thank you.
Thank
Yeah,
you.
my pleasure. And thank you for asking such brilliant questions. You guys are great. Thanks.